get the show underway. A word of welcome to everybody, and firstly, thanks very much to Dr. Phil here and all the administration at Moorepark for having this fine centre to present the lecture. This is the, can everyone hear me? It's the third of the three lecture series on dairy processing. A very topical subject at the moment in engineering and I suppose other areas of the commercial world. It basically, the concept was to cover all areas that are likely to be, I suppose, the primary issues to address. And maybe the last came first, but so be it. The important one, I think, is, as I always have contended, is the baby has to be conceived. And this is the baby being conceived. In other words, the basic research and the research and development of the product. After that, the design of a system to be able to make the product, and then what happens when you make it, how do you handle the obvious from it. Now, the last lecture, lecture number 2, covered the area of design of treatment work and not treatment works of manufacturing centres, large-scale processing centres, like the recent one that was done, for example, for Bellevue, for Glanbia, but any of those, you have them for any of the large the groups at the moment. And the first one covered the area of the wastewater technology that relates to the industry. It's an important area, definitely an important area from the point of view of starting the business now as time goes on. It's a difficult one if we want to get formal planning, etc., for any of the developments. So the third one, as you can see, and this one tonight, is given by Dr. Noel McCarty, and it's on the process technologies for the Irish dairy industry. Now, it's what is a wide topic, but on a deep subject, if I can say it in my own humble way, that way. Dr. Noel has graduated in 2006. He's a PhD in basically food science, has been doing a lot of research, has worked with some of the bigger global organizations like Abbott, and he, I suppose, at this stage is at the center of what is new thinking, new process development. So I think without much further say, hopefully when Noel completes any topics that need to be queried or discussed, that's what the lecture is principally about. So the more contributions from the floor, the better. So in that sense, Noel, possibly you could take over and we will listen. Thank you.
Thank you very much for the introduction. I'd like to welcome to your Charles Moorepark this evening. I know it's late, but I think it's going to be well worth it in terms of the overview of what Charles has to offer and what Charles is about in terms of its research and development that goes on, particularly within the food chemistry and technology department. So the vision, what is Charles' food programme mission? Well, it's to support science-based innovation in the Irish food sector, so as to underpin profitability, competitiveness and sustainability. And I think that really is the core factor of Charles and Food Chemistry and Technology Department, is that it has to come back to industry and it has to be relevant. And we've just put in some examples of some products that have been linked with Charles and are now on the market. And I think that's very important when we look at research and development, that there is an end use, no matter how far down we go into the molecular side of things, that there is an industrial and a scale-up position taken. Just an overview of the campus here at Charles, for anybody that doesn't know. The food biosciences area, so we're based here in the conference room this evening, just here at the front, and the food biosciences building is towards the back of the conference rooms. The food chemistry and technology department, where I'm based, is here, and at the moment actually there's further development, but just goes to show where the food industry is at the moment, and in terms of development and the infrastructure that is needed. So right here, there's a new development for new laboratories, new space for students and postdocs, and particularly with new initiatives like the DPTC and other projects that are ongoing, there's a huge increase in the number of students and staff within the department. Moorepark Technology Limited, well, this is really core to our sector, and that's where the pilot plant facilities are situated. There's the pre-commercial, which is at the back of the site, and we have a pilot plant, smaller pilot plant scale, which really we come from laboratories here into the pilot plant, the biofunctional engineering department, the BFE, and I'll go through that a little later. We also have industry based on site, but we also have industries based within the food chemistry and technology department. So they're really interested in coming down, getting into the core of the work and the science that's here at Moorepark, and they see real benefit from that. So, you know, that is the overlay of Chagos Moorepark and the food hub, basically. Just in terms of research funding and opportunities, so the statutory remit to undertake food research and development, and there's a number of different platforms. I mean, we're tied in with Food Harvest 2020 food-wise, but then there's UCC, UL, Dublin City Universities, the list goes on. But also in terms of funding, like FIRM, the Food Institute Research Measure, we get a lot of our, I suppose, our scientific funding, which is the real basis to drive the industry. And we get that through funding programs like this, and also within Food Ireland. It's important to mention FHI, Food for Health Ireland, and the department. So the food programme, it's basically based in two sites. Moorepark here, based in Fermoy, County Cork, and Ashtown up in Dublin. Currently there's around 286 research staff and students across the two centres, and there's 4 diverse departments spanning both centres: the biosciences, chemistry and technology, industry development, and also the food safety. And just to mention, probably because it is the core, it is looking at processing this talk, and I think from the beginning we need to mention Moorepark Technology Limited and their capabilities, the pilot plant, because this is where all the work in terms of from students, postdocs to industry, this is where it's carried out. And the general manager, just to give him a mention, is Kieran Downey, and I'll just go through some of their capabilities very quickly in terms of the different areas within the biofunctional engineering and pre-commercial scale Moorepark Technology Limited. So there's 3 scales here in Moorepark in terms of pilot plant facilities. We have small scale, so this is just above laboratory, and it's really based on terms of its flexibility. That is the key and the source and the key to the actual success of the pilot plants. We have small scale, which is roughly determined by our spray dryer. It's a single stage spray dryer, taking out roughly 10 kgs of water per hour. We have a 3-stage spray dryer down here, and then hydrous 3-stage spray dryer, taking out roughly 20 to 30 kgs of water per hour, depending on the product. And then we have pre-commercial scale, which is taking out roughly 100 kgs of water per hour. But again, the key here is the flexibility that companies, students, staff can come in and design a process that suits them, whether and depending on what scale they actually want to go to. So I think it's probably the key the key to the success of Chagos, really. Just in terms of dairy ingredients and infant formula, tripartite collaborations with suppliers, next generation manufacturing processes, new formulations, new ingredients for use in infant formula, also the production of highly skilled graduates, science of milk to finished product, customised training courses, and those training courses are given to industry, so they will come in, we will prepare a number of lectures on a particular topic, and we disseminate that to the industry. And I think if we add all those together, that really covers the research programme and the dairy ingredients and infant formula. So, delivering R&D solutions to the food industry. What are the main overlay topics that we cover? food fermentation in terms of cheese and fermented powders, food ingredients, the commodities such as skim and whole milk. And we've looked at that right through from thermal processing to evaporation to spray drying. In food and health, looking at molecular level, the protein, carbohydrate, fat, probiotics, prebiotics, metabolic control, exploiting the health benefits of the Irish dairy produce. In food safety, pathogen detection and control, food protection, quality by design, mapping factory microflora. So going into factories, looking at what is the microflora throughout the process, from the very beginning to the very end. Improving quality standards in meat, developing novel ingredients, again takes place up in Ashdown in Dublin, in cereal and bakery and beverages. So these are the main areas that the food programme covers. In terms of the major dairy processors in Ireland, there's quite a few down in the south. There's also a number up the top here. Town of Monaghan has recently changed its name to Patrick, I think it is. So, but there is a number, there's 4. This is not including the IMF companies, just the dairy ingredient companies. So, there is expansion, with the target of 50% increase in milk production by 2020. Well, this is what's going to fill the capacity of these plants. But what are these plants actually going to do with this milk and this excess milk? Well, it's got to be exported, and it's going to be exported globally, particularly to Asian markets, China, Southeast Asia, Australia, South and North America, Africa, and within Europe, and particularly in the form of IMF. So while they will export commodities such as whole milks and skim milks, a lot of it is in the form of IMF, infant milk formula. And milk processing, we are strategically committed. And why? Because of the expansion that the dairy industry have put in over the last number of years. We've got to keep up with it in terms of the science. They are keeping up with the expanding milk pool in terms of the money that they're spending in expanding and developing new processes within and new plants within Ireland. And I think Teagasc is very lucky in terms of location and based on a dairy farm. So therefore, we can take milk from the cow, which is only situated 200 yards away, and process it directly. So we can take in raw milk, we can make our cheese, we can have an anhydrous milk fat, we can do a number of membrane filtration steps, we can separate into different protein fractions using the membrane filtration steps. But we also look at hydrolysis of lactose, fermentation processes in terms of yogurt production, and other beneficial and health beneficial products. So I think we're very lucky in that sense here where we are based in terms of getting fresh, raw milk straight from the farm. Integrated factory designs for maximum synergy and added value strategic thinking. Well, what does that mean? You take in raw milk. Now, if you skim it, the amount of in-uses through membrane filtration is numerous. In terms of micellar casein isolate production, whey protein isolate production, casein macropeptide production, you also can separate into lactose, calcium salts, milk salts, oligosaccharides, enzymes, and within the cream we can make anhydrous milk fat, buttermilk, and phospholipids. So matching the product portfolio to the business model, we need to do something to it. We need to make them highly add value to these products. So while we have our basic commodities like skim and whole milk and milk powders for export, we can also add value to them, whether it be adding additional minerals or vitamins for stage nutrition such as infant formula or nutrition for the elderly or for sports. I think that's key here within the department. We have very good research in terms of cheese and fermentation in terms of yogurt, and I think that's really key to the department and Teagasc. So just to delve a little bit into the processing now side of things and how we see the future of processing in terms of what are the new trends and what is some of the work that we've carried out over the years. So this is a diagram of a typical, it's probably a typical infant formula process, but it can be true for any whole milks, skim milks, products as well. We have batch makeup, we have a heat treatment, homogenization, we have holding tanks, we have evaporation, and we have spray drying. And we use this throughout processing, and we take samples either through after thermal treatment and homogenization, after evaporation, and after spray drying. And a little later, I'll just go through some of the analytical techniques that we use to analyze these samples. In terms of new processes, and I think this is key to even the slide where I mentioned Food Institute Research Measure, and in terms of funding, some of the actual funding that we've got in the past, what have we used it for? I think it's very relevant to industry, and this is just one example where we look at adjusting amino acid profile of infant formula in a way that makes commercial sense. It reduces energy costs, and just to explain it, a lot of infant formula processes involve the taking in of dried ingredients, where it be dried skim milk powder, whey protein concentrate powders. These powders have all been through a history of processing prior to reaching the infant formula manufacturer plant. They are then re-wetted, blended, evaporated and dried again. The basis for this project was basically to look, well, at the milk producer, at the milk ingredient site, can we do something here to have a straight through process, that a liquid stream can go straight to the infant formula manufacturer and is ready to be processed. Through membrane filtration, we have adjusted the protein profiles of skim milk to that of similar to human milk, or more similar to human milk, in terms of amino acid profile, through membrane filtration. And upon that, we can blend in our minerals, our fat blends, our vitamins, our carbohydrates, and there it can go to evaporation and spray drying. And I think these are the kind of projects that are very close to the thinking in the food chemistry and technology department. And while we do this, it's not much use if we just do it and we leave it there. We have to go out and disseminate it. And I think that is the key. We are so close where we're situated to so many ingredient companies, and we go out and we approach them and we show them, here's our thinking. Maybe it's not exactly how we would do it in your site, but here's the idea. And I think that works very well. So what are Teagasc's capabilities in next-gen IMF and ingredients? Complete milk fractionation, so microfiltration, ultrafiltration, nanofiltration, reverse osmosis, electrodialysis, ion exchange, can all be carried out at pilot plant scale. New concepts for liquids, concentrates, powders, robustness studies on plant and membrane performance, so studies can be carried out over a number of hours to look at fouling and membrane filtration process performance. Feasibility studies, integrated mass balance and process flow design, CAPEX and OPEX and business case evaluation. So it can give companies an estimate. If they come in and they use a particular membrane in NTL, they can go back and see at a certain scale that their CAPEX and their OPEX. And I think that works quite well. Capability to rapidly modify and construct membrane plants to meet customer requirements. And the scale can vary anything from kgs to tons. And we can even go down into laboratory scale and use milliliter levels. So, just a quick look at what the plants look like. The ceramic MF, the organic MF and UF plants, the multi-membrane plant, which has microfiltration, ultrafiltration, nanofiltration and reverse osmosis, is very, very useful in terms of separating skim into casings and whey, but also further fractionation down into separating beta-lactoglobulin, alpha-lactalbumin, and also looking at performance of the membrane plants in terms of transmembrane pressures and permeate flux. Chromatography and electrodialysis. So heat treatment of dairy-based products. I'll just touch on this small bit. So the effect of heating on bovine milk components in IMF. Well, it has to be heated because it has to be microbiologically safe. We want to inactivate any enzymes, but protein structural changes resulting in inactivation of functional proteins. So we get denaturation, we get aggregation. And it's very important to remember that while some heat treatment processes will work for one system, they will not work for another. And that's based on the recipe design. I'll touch on that a little later. It is very important to take into account what is in your recipe, what are the mineral profile, what is the levels of native whey proteins within that formula. Moving on, Maillard reactions in terms of carbohydrate and protein interactions, and heat toxins. Many nutritional beverages are high heat treated as opposed to UHT, meaning we high heat treat them and we dry them afterwards. Infant formula here in Ireland is a typical example, whereas in the States they use a lot of UHT and retard sterilized processes for ready to feed products. Options include DSI and infusion. DSI, direct steam injection. Basically, these DSI and infusion are where steam directly interacts with the product. Tubular, indirect, means the steam is outside, there's no interaction between the steam and the product. All systems are challenged by high dry matter processes. And I think that's a challenge for everybody in terms of designing plants, designing recipes. They are very much limited limited in terms of dry matter process. So what are your solids? High heat treated requirements are met primarily in the holding section. Typically the holding tube section is the initial zone for fouling. And again, that comes back to the recipe in terms of mineral, protein profile, so on and so forth. Direct steam injection systems for high heat treatment. Direct steam injection, contact of product and steam. Many injector variations are available, Delaval nozzle, and annular gap, multi-nozzle. Performance is good at a total dry matter up to approximately 25%. Running DSI systems at higher dry matter can give major fouling and or product stability issues. But again, it's very much recipe dependent. And that's why a lot of these heat treatment systems are designed prior to evaporation as opposed to post. And of course that has its problems too in terms of direct steam injection, and the heat treatment is a critical control point, but now you have to go and evaporate and then dry. It would be much better if we could heat treat and then dry rather than have a step in between. Disadvantages, OPEX associated with irrecoverable energies, product quality issues, reduced CIP intervals, increased filter changeovers, steam requirements. The steam has to be of culinary grade, so it's filtered with pore size less than 2 micrometers. And the pros and cons. Pros, high local heating rates by direct contact with steam or vapour, simple and small construction, simple to control temperature and time, no additional pumps, low investment costs, minimum floor space waste. Cons, running time and high total solid products could be restricted by the build-up of fouling. And that's often the case because of low turbulence within the DSI and particularly at high solids. Thermal processing here is just an example of our thermal processing facilities within Moorepark. This is our microthermix, it's tubular heat exchanger, indirect heating. We have a holding system here, external holding system, so we can hold at 140 or 100 degrees Celsius for a set amount of time. We have an homogenizer at the back here. That homogenizer can be pre or post heat treatment. And we're finding very nice results actually recently from this, whether you heat treat prior to homogenization or you homogenize and then heat treat. And it's not so much that it's a case of you see viscosity directly after the heat treatment and homogenization process. You see it more upon concentration. When you go to 45, 50% total solids, that's where you start to see the increase in viscosity between the pre and the post heat treatment during homogenization. The direct steam injection unit was designed here at Moorepark, and I'll just go through it. There's a bigger picture here of it. So we have our flash cooler vessel, our injector, our steam valve, side glass, and the holding tube on this is often where the problem is in terms of DSI, where you see fouling. And what we're trying to do at the moment is trying to reduce that holding tube. And I go through it a little later where we're looking at reducing microbial load through membrane filtration prior to high heat treatment temperatures, so that the holding tube can be a smaller holding tube, less time the high temperatures and therefore less fouling. Alternatives to DSI, steam infusion systems for high heat treatment. How does it work? Essentially, this falling stream heater. Product enters the vessel at approximately 70 to 80 degrees Celsius via multi-nozzle distribution plate. So over here the product is coming in, or steam is in the vessel, and important not to have air in the feed. Product is heated as it falls from the top of the vessel to the bottom in a laminar stream to from 135 to 45 degrees Celsius. Cooling jackets at the distribution plate and vessel outlet create a layer of condensate which inhibits fouling and protein deposition. Product enters a holding section, in this case a rotary lobe pump, which provides a defined holding time. Temperature control and hence steam pressure in the vessel is determined within the pump, so the flow rates. Product is immediately flash cooled under vacuum at the exit pump. System can handle high dry matters, and MTL continued to invest in a system in 2016. So innovations in heat treatment and sustainable smart processing. So I talked a little bit about fouling and protein aggregation, and it's recipe dependent in terms of minerals. So this is the typical process where we heat treat at low solids because we can't do it at high solids. We homogenize and then we evaporate, and then we go to the spray dryer. But what if we took out the heat treatment step there at low solids, the homogenization and the evaporation steps? And we made up the batch at high solids. And we skipped this and went straight to the dryer. Using the shockwave steam injector, the McCarty's shockwave steam injector, this was made possible, and just a little demonstration. So no evaporation step, less water to remove, lower energy requirements. So now we must be able to heat treat at high solids without fouling, but also be able to homogenize. Basically, this is how this works. Steam inlet, it hits a choke, so its steam is accelerated through a nozzle to supersonic velocity. This pulls the product in. Mixing zone, so the steam and the product now mix. Steam and formulation mix to produce a two-phase mixture of liquid and gas vapor. Upon condensation, the condensation zone, we get steam condensing releases latent heat, a shock wave is produced resulting in high shear. So from these studies in the pilot plant, we were able to process at approximately 60% solids, we were able to heat treat them, and we were able to emulsify them and go straight to the spray dryer. And this technology has been disseminated to a number of industries, which was very well received. It was presented at a spray drying conference in, say, Mallow, and it was very well received there in terms of, if it's not suitable for one company, at least they know this technology is out there, and it gets people thinking, and that's what this is about. Staying with the innovations in terms of fouling and heat treatments, this study looked at the protein profile of infant formula. And one of the major factors in fouling is the whey proteins, particularly the beta-lactoglobulin. But beta-lactoglobulin isn't particularly wanted in infant formula because infant formula is based off human milk, and human milk has the majority of alpha-lactin, lactoferrin, and other proteins. So what they decided to do was, well, what if we hydrolyze the beta-lactoglobulin? Do we reduce the fouling, but now we have peptides in there? How is the emulsification properties of that? Are they affected? So they were able to selectively hydrolyze beta-lactoglobulin. And if you look at the third lane, you see alpha-lactalbumin, the beta-lactoglobulin is gone. That's because it has been hydrolyzed, it is in peptide form. So, if we put this through our process, we have a control, and we have our experimental selectively hydrolyzed. We make the batch up at 55% total solids, and we process both of them separately. Well, after heat treatment and homogenization, what's the particle size like? This is our selectively hydrolyzed, this is our control. Standard deviations probably show that it's not that much different, which is very, very good and very, very interesting. And that's because the intact alpha-lactalbumin was able to emulsify the oil, as opposed to just having peptides, which is often the case in hydrolyzed formulas. We were then able to go to the spray dryer at 55% solids, and we saw a huge decrease in viscosity. So we were able to make a good emulsion, but reduce the viscosity. Now, if we reduce the viscosity going to the spray dryer, there is other alterations that need to be made in terms of spray drying. You have lower viscosity, therefore you might have changes in your fines return. Your pressure after the high pressure nozzle will be different. Your moistures might be different. Your air inflows and outflow, your inlet and outlet might be different. But these are all things that can be changed readily. The main thing is that we were able to reduce the viscosity going to the dryer. Therefore, we're not going to see build up in pre-filters to the dryer or block nozzles at the dryer. And this has been published, and actually the hydrolyzed beef lactic goblin is carrying ingredients and flavours, and this was published back this year, I think it was, by Owen Murphy and Mark Finlay. And just leading on then, in the formulas and in processing, there's a big change and a big, I suppose, drive towards high protein products. And a lot of them are just your commodities like whole milk or skim milk or low fat milks. And what a lot of industries are doing is just increasing the protein content by adding dry ingredients like high protein powders like NPCs, WPCs. But one of the main issues with them is their hydration, and therefore their subsequent functionality is very much reduced. So there's a big drive within our department to look at ways of mechanical agitation in terms of hydrating powders. We've looked at it from a chemical point of view, where you're looking at calcium chelators, bind free calcium ions, dissociate casein micelles. But on the other hand, there is a mechanical way of doing this, because when you add calcium chelating salts, you're changing your recipe, and that's not always feasible. So, if we look at powder particles within the beaker, we see a powder particle size of somewhere between 10 and 100 micrometers. This is for an MPC. After initial ultrasonication, we see the de-agglomeration of the powder particles, so we get bimodal size distribution. Somewhere here around is the size distribution for casein micelles. Here is undissolved powder particles. If we keep going, eventually we'll come up with a monomodal size distribution representing casein micelles. Now, the key to this is that the time between initial ultrasonication and the end is very, very short. Compared to high shear mixing, it is very, very short. And that's really where we see a benefit for this type of system. Also the functionality, whether these MPCs are going to be used in fermentations or yogurt, so you want good gel strength. This could be a very, very useful technique, and it's published in Journal of Food Engineering with Phil. And just carrying on from there, I just want to mention some of the rapid offline testing capabilities to support pilot plant activities. So while we do all this processing, we need ways to go and show industry, our scientific peers, well, what are the differences between all these different processes. We've got microscopic capability, we've got rheology capability, we've got morphology on powders, so we can look at the shapes. So if we change nozzle sizes, if we change inlet and outlet flows, if we change agglomeration modes, we can see the difference in the morphology of the powders. We have size distribution for both liquid and powders, so we can monitor the emulsion stability in line during the process, but also on the finished powder, the bulk composition of powders, and the flowability. So we can analyze our 3 different dryers in terms of the flowability of the powder using this machine. So again, if we change agglomeration, if we go single stage drying or 3-stage drying, we can see the difference in the flowability of the powder using this. Thermal transitions, again very important. We can look at it both liquids for protein denaturation, but on the other hand we can look at it in terms of powder stability, and particularly in terms of lactose crystallization. Again, very useful. In terms of emulsion stability, so after homogenization, we can look at how well we can use it in conjunction with the master sizer for powder particle or for fat lobule size, and we can look at premium sedimentation rates, mineral analysis. So if we go membrane filtration, we can look at the levels of calciums and free ions in the permeate and retentate streams, the macronutrients in terms of size exclusion, reverse phase HPLC, and the hydration behaviour, looking at the uptake of water in powders, and again we can relate that to the thermal transitions in terms of lactose crystallization at different humidities. And just to show some images from the microscopy facility here, some confocal, some SEM microscopes are images of powder particles, and we can see vacuoles, we can see the agglomerate stuck to the primary particle. Here we have a confocal image of a powder particle, and we can see an air vacuole, we can see fat globules present in the powder particle. So the innovation, what areas in dairy are hot right now? Well, the removal of bacteria, including filter sterilisation. So cold processes where there's no need for heat, where we can remove bacteria in terms of membrane filtration. Phospholipid enrichment, tailored amino acid sequences from milk and whey through selected enrichment of protein fractions. And I think I'll talk about that in the next slide, where we see here a whey stream from cheese. So we've got our whey proteins. But from the cheese manufacturer, we've got casein macropeptide, which is a peptide, but it's a casein peptide, and it's often counted in terms of the total whey proteins, when in fact it probably shouldn't be. And through membrane filtration, we're looking to clean that up and have a pure whey protein system from cheese wheys. Maintain native structure, so improve digestibility of proteins. This is a big driver at the moment in terms of heat treatment in processes. They're looking to reduce the heat treatment while remain microbiologically safe, so it improves the digestibility of the proteins. Maintain biological activity of targeted enzymes, reduce protein degradation byproducts associated with heating, such as Maillard reaction toxins, retention of higher bioavailability of milk salts through selective partition of minerals, and retention of higher levels of trace minerals and vitamins. And particularly with the vitamins, a lot of the vitamins get destroyed through the heat treatment and they're added in after. If we can maintain a lot of these vitamins, it's only supplementation is what we're looking to do, not starting from scratch. And I think that's an important point. The dairy ingredient world is changing, and what are the trends? Well, food safety. Food safety is still a major challenge. Fonterra crisis highlights vulnerability in the sector. Research needs to consider state-of-the-art processes such as state infusion, low-temperature bactification, low-temperature microfiltration. There's an awful lot of research to be carried out, and we see these as the main drivers behind that. EFSA 2014 publication will be translated into the EU regulation in 2015, and the panel considers that the content of Maillard reaction products and protein degradation products in infant and follow-on formula should be kept as low as technologically possible. And what that means is that you've got to remove heat at some point in the process, but yet they will look to make sure that the product is still safe. And that is, I suppose, the major factor and the limiting factor in removing heat from any process, is that can you ensure quality. And just a little bit on capability in terms of membrane filtration and next generation processes. And this is actually going back to the project proposals that in terms of FIRM and Enterprise Ireland, where we look for funding. And this is the sort of diagrams that we want to carry out, and the process flows that we want to study. So if we just look, for example, whole milk, cream separator. We take our cream and we keep it until we actually want to maybe standardise skim milk later. The skim milk can be passed through a 1.4 micrometer ceramic MF membrane. Therefore, there's no heat. We've removed a lot of bacteria and the spores. The skim milk permeate then goes through an organic 0.08 micrometer MF membrane, and from that we get two streams. We get the whey permeate out, and we get the casein fraction coming back up, which can be heat treated and readjusted or reset and standardised with our cream. The whey permeate, native whey permeate, comes down, and we can now concentrate that using the 10 kDa organic UF membrane. The retintate can be passed through the RO to remove water. Therefore, we are concentrating, without the need for evaporation, we are concentrating our whey proteins, and we can send that to the spray dryer, making a WPI, WC80, WC70. The water can get reused in terms of diafiltration to remove the whey from the initial skim coming in. The permeate from the UF can be RO'd. It can, the UF permeate can come, the UF permeate or the RO permeate can come up, and we now have the casein, the cream, but we also have the milk salts to go back in and make our cheese, because the mineral balance is very important. So from that we can make our cheese, but now we have a cheese where when we rin it, we've got no whey proteins. So when we rin it, we create CMP. The CMP can be concentrated up using UF membrane here, and now we've got pure CMP. Now, it's not so much whether somebody wants to look at CMP or not. It's more the capability. It's more the idea that this is possible. Whereas before, maybe industries might not have looked at. They were busy with looking after the commodities like the skim and the whole milk. But these are more to show the idea of what's capable and what's capable within Chagas in terms of membrane filtration. And what you can end up with is a cheese with no and a native whey protein, and it's like macropeptide powder. In terms of filter sterilized milks, again, very similar. We can bring in our whole milk, raw whole milk. We can separate it. We have our skim, pass it through the 1.4 ceramic MF. We get a permeate of the milk. We can pass it through a 0.2 micrometer organic MF. We can get skim milk, pure liquid, and we can concentrate that using RO up to a certain level. We can evaporate up to 55% solids and then spray dry it, and we get pure milk powders with very low heat treatment. So I think in terms of membrane filtration, there's numerous paths to separate milk into different fractions, and we are looking at ways, and this is I think coming down the line, of ways of minimizing the heat treatment in terms of from a nutritional point of view, but also we have to make sure that it's also safe. And I think that's very important in terms of efficiencies for industry and in terms of processability and what's feasible for them. It's not that we tell anyone to go and do this, it's more that this is here, this technology is available, and the pilot plant is the place to do it in terms of what's feasible for your plant. I think that's very important. I think that's kind of it. I just want to mention, on behalf of Phil, the IDF Parallel Symposia from the 11th to the 13th of April next year. Dairy products, concentration and drying, and cheese science and technology. And I think we'll have a lot of presentations and posters at that from Charles. So I think I'll pass it back over to you and for questions or anything.
Thank Tom. That was brilliant, to say the least, presentation. I studied food, would you believe, in my early days in college, but I think I took back the secondary school. But some brilliant points come out, as far as I'm concerned. This concept of further development, it came at the end there, but obviously it's the big issue of the future for us all, because what was at one stage waste product, namely whey, is now a product to be further used. You have retentate in recent times that came off RO systems, was a massive waste product, and the big problems when it went down the sewer to be treated and all the rest. It's now potentially a recyclable product, and that's the great news to hear in all this. It introduces this thing of recycling, minimising product loss, and obviously it I think accords with the requirements of the EU at this stage, and it's setting a brilliant example for the country, and I would say it that way. Hopefully the rest will follow. The work that's been done here is absolutely brilliant, and a word of congratulations to them all for the effort that's been put into it. Now, straight away, can I ask somebody to make a comment? Has anyone a query? Whatever. Sean?
So Noel, well done. You started off with a stream through your talk, Noel, is the importance of infant formula, maybe for people who are not familiar with the importance of it in the Irish food sector. Would you kind of say a few words about the scale of it and how important Ireland is as an infant formula and production based country?
Yeah. Yeah, thanks, Sean. I mean, it's extremely important from a product point of view, where you're looking at commodities, taking in the likes of skimp. So all commodities that dairy ingredient companies are making at the moment, a lot of them are going in towards infant formula. Looking at the whey protein size, looking at skim milk, lactose crystallization and lactose use. Infant formula is mopping up quite a lot of that. We have Danone, we have Nestle, we have Abbott Nutrition, but that's not just to say within Ireland. The dairy ingredients companies then are exporting powders throughout the world, particularly to China, and looking at these powders going further afield into IMF production. Particularly within Asia, I think the infant formula, the mopping up of infant formula and Irish dairy ingredients is huge, and particularly even within America, where they're looking at retort and UHT sterilized products. And I think the challenge for dairy ingredient companies is that their products remain stable when exported. So while the majority of them and a lot of them are going to domestic and local IMF producers, there's a big export market there, and I think that's a challenge for everybody, and that's one of the challenges that I touched on just there in terms of rehydration, that we need to be world leaders. We need to be up with the likes of New Zealand in terms of rehydration, that when plants from further afield take in Irish dairy products, that these products are exceptional in terms of functionality. They like the fact that it's coming from a grass-fed diet, and I think that's essential for the industry, and particularly in terms of research here. And just to touch on the Science Foundation Ireland and Forum, I think that's the way we see research going, is that we want to be at the forefront of that. We want to go out to industry and tell them, listen, here's the way these end users are going to, this is what the product's going to, end users going to end up in, and here's the difficulty. And I think for ourselves, we're at a great advantage in terms of what we have on our doorstep that are mopping up dairy ingredients, and I think it's a huge potential. The majority of infant formula, the compositionally, comes from bovine milk, just in different fractions. Besides from the fat and the cream from bovine milk, everything else is in there, along with then they add minerals and vitamins. But compositionally, infant formula is mopping up a lot of the ingredients that bovine milk has. They're just switching it around, chopping and changing. But I think it's huge, and it's going to be huge right into up to 2020 and beyond.
Yes.
Well done, Noel, for a very good presentation. Even old guys like myself can understand this. But one of the two things that I want to ask you about, one was you mentioned heat toxins, and it sort of came up when it went away again. How important is that? And the second thing is that you were concentrating exclusively on the protein lactose. So there was nothing in turning up on the fat side. Is there any activity in that area?
Yeah, thanks for the question. I mean, I may have to bring in Phil on this as well. From a possibility point of view, obviously we're always looking at the protein degradation, denaturation, in terms of uses for the fat, in terms of butter, oil, anhydrous milk fat. We are looking into it, and I think if you, Phil, have anything maybe to add.
I'll let you.
Yeah, so I mean, in terms of myself, it's probably my own expertise always lies within the protein side and possibility. And I think that maybe that is true because IMF seems to be at the forefront of innovation, and we kind of link it back then and we take the developments from that and we link it back into all other commodities. But the IMF companies aren't looking at fat, they're taking in vegetable fat. And I think that's true that, you know, maybe the fat content and what can we get from that. Phil has some expertise on the phospholipid side, but I think it is known here within the department, and it is something that's coming around again that we want to bring up that side of knowledge within the department.
The poor relation at the moment.
Poor relation at the moment, but there's a lot of there's a lot of interest in it. Yes.
Yeah, there are two, I suppose, strands to the fat issue. One is the major bulk relating to which is the triglyceride fat, and the second one, which refers to the minor constituent, which is the phospholipid, which is largely associated with the emulsifying layer in the cream, which we are able to, I suppose, recover now as a byproduct stream from the buttermilk in butter manufacture. You're right to say that fat research is a bit low-key on the program at the moment. Now we have one, I suppose, line of investigation, which is actually based on intercertification at the moment, and it is, I suppose, again, aligned and driven by the infant formula developments. And that work is actually happening in the FHI, or Food for Health Ireland project, which is an industry-led project. And I suppose the opportunity from the industry point of view there is, and it relates to, as Noel said, it's the fat that is used in the infant formula sector at the moment is primarily non-dairy, because it is what we call a humanized fat, which has relied on, I suppose, adaptation of the composition in terms of triglyceride, fatty acid content to match kind of human milk, but made up largely of, I suppose, vegetable oil sources and supplemented these days with what you might say marine lipids of the omega-3 kind of fatty acids. The research that we're doing right now in terms of the intercertification is actually to try and see how we can align, you might say, the structure of the fatty acids on the triglyceride molecule, where in the case of human milk, the attachment of one fatty acid called palmitic fatty acid is predominant at this kind of chemical position called SN2. And our guys here, which include Sean Hogan and myself, and we're looking at enzyme-induced type of modifications, and we're making some progress in that direction, and also kind of use it in conjunction with a blending process in order to see how far we can go in terms of, let's say, getting milk fat back into the blend. So that is, as I say, one strand, which is, I say, kind of nutritionally driven. Now, there is another project which we will be embarking on shortly, because the industry, like as much as you have mentioned, is on the same wavelength in the sense of where is the sort of next direction to go in terms of milk fat research. So through this new, what do I say, virtual enterprise centre called Dairy DPTC, there is a fat study Initially, it's going to take them, in fact, it will start in January. It's a desk study, and it's going to look really at, I suppose, where milk fat processing is at globally, and where are, we said, the developments, happening with a view to and in conjunction with the industry, I suppose, finding the strategy and the tools to say, okay, the next direction we should take milk fat would be whatever X, Y, Z in the light of that study. So it's kind of a long-winded approach to be able to saying that there are things happening, but in fact, in the process, we probably will start by picking up a lot of what was done in the past, and indeed yourself, Joe, was involved quite a bit with that, because there is quite a bit of resource here already in Moorepark, albeit some of the guys here might need to be reminded of it now, because of the fractionation work that was done, the studies in relation to the variability of fatty acid compositions in milks, the bottle hardness studies. As I said, there is quite a bit of technology already in the system, but as I say, fast fitting into frozen storage.
And what about the other question, the thing that scared me about the heat toxins?
Oh yes.
Because I associated, heat damage and carcinogenics, but not toxins.
Yeah, it's something that's come up. It's always been there, but with the tightening up on regulations, I suppose, the likes of, and Seamus and Annie and UCC has some experience with this. These things in terms of protein quality now is really becoming to the forefront, particularly in infant formula, and interactions between carbohydrates and proteins. It's something that we need to start looking at. Up to now, there's been some work done, but it's not been really in terms of a research project. And when it's not in terms of a research project, we're not getting the time and funding to even look at it. And that's what we really want to start delving into. And even just to mention, we're myself and Seamus, and we're hoping to go down this route in terms of looking at these byproducts and these toxins, and setting up methods within the department to look at them. It's all dependent on the funding, but that's what we are writing a proposal at the moment based around this. I thought it was important to mention it just in terms of what the industry are looking at.
Unless Seamus wants to.
I might just follow.
Oh yeah, do
More so than a contribution or a comment. I do question though.
Oh no! Help a man out there, Seamus.
Well, no, I suppose first, maybe just go back to the carbohydrate question. Yes, there is a certain amount of work going on in that space, but it's mainly looking at trying to modify functionality of proteins by attaching carbohydrates to them and using the Maillard reaction. There are some limitations associated with that then with Maillard reaction products and some anti-nutritional properties and so on. So that's the scope of the ongoing work. And there's some future work planned then around high temperature treatment and production of certain nutritional compounds under those conditions. So first of all, thanks very much, Noel. It was a very nice presentation and very clearly put together on what is a difficult, very broad-ranging topic. I suppose one of the themes that was coming through obviously was processing and processing developments and so on. And you gave, I think, one or two very nice examples there towards the end where you integrate technologies. Many of them may be existing technologies, but integrated in a fashion that they wouldn't have been previously to generate ingredients with desired composition and functionality and so on. I suppose what's often more challenging is new technologies when we're talking with the industry and so on. Maybe it's a bit easier when, like the examples you gave, there's a clear need. It's we want to minimise heat treatment or want to engineer in certain functionality. But do you have any comments to make or observations, from working very closely at the interface with industry, on what it is they're looking for in evaluating new technologies and developing new technologies and implementing new technologies? As I say, it's a bit easier when you have a clear need at the other end. But how do you manage that? Like you mentioned dissemination, for example, and industry technology transfer and scale up. Do you have any comments or pointers on that maybe?
Yeah, you're right, Seamus, because in terms of these technologies, sometimes you could go to industry and explain yourself, and here's a nice technology that's working at 20-litre scale, and they'll say it's very nice as well. But they'll say immediately after that, not applicable to us. So how do we deal with that? In terms of ultrasonication, I think it's a nice example. There's the next gen IMF, which is the membrane filtration to adjust amino acid profile. But just on the ultrasonication, ultrasonication has been around for a while, but why isn't it being used? If it's this effective at hydrating powders, why isn't it being used by the industry right now? But that's not to say that the industry aren't coming in to do research on it at the moment, So while it's not maybe for next year in terms of their development plans, it may be 5 years down the line, but in terms of just from my own point of view in terms of ultrasonication, I think it's highly relevant. What they're often afraid of though in terms of these technologies is, well, first of all, it's expenditure. That's what they're afraid of. The CapEx, the OpEx involved, it takes time to actually see what's actually involved in running these pieces of new equipment. That's why, from our point of view, we develop first, then we go back and we try to optimize. So for ultrasonication, we would try to put that in line. Whether that's either with the sonication probe or using non-contact probe, so it doesn't affect sensory of powders, things like that. But it's all trial and error. But that's the good thing about where we are. That allows us to do it. But we have to go out and explain it. If it doesn't get explained to them, no one knows about it. And especially even where the isolation of the CMP, the industry there are existing technologies, but sometimes they're not used in the right way. They're used for either just making casings in whey, or they're just concentrating using RO. But there's a whole array of other technologies around it. And you are right in terms of the dissemination. But I definitely think now that the industry are much more open to it, and they're much more open to try and see. The ultrasonicator, as one example, has been very well received within the industry. The next question they ask you is who has it? But I mean, it's something that they see that's relevant, and that's why we don't want to go with technologies that are too far-fetched, that are not really applicable. That's why we want to come back and even the shockwave, with the membrane filtration systems. They are something that can be done, that they can do. But you are right in terms of it is up to them to take it on, and often it's up to them maybe to come in and do their research on it as well, on their own and with the help of ourselves. But I think the industry are much more open now to looking at new processes, anything that saves them in terms of efficiencies. But again, they are looking at the capex and their expenditure. And I mean, you can only explain it. You can't go in and ask them straight away to take it up.
I can add maybe a little bit
Yeah.
to here. Noel is right, and I've seen on a number of occasions, where you might have some great ideas, and in fact, you often see there on textbooks and probably on the internet this classical curve, which great ideas and a big burst of activity, and then you reach the peak and peters off. And especially in big kind of projects, you have to ramp up through the financial feasibility. You're doing the sort of pilot plant and the validations and then you reach a point, you're almost there, like somebody does like the cost per unit of will make a whey process, and suddenly like it just comes out marginally too high, and the whole thing just stops. The second point I just wanted to mention was that It is a good question in the sense of any research institution in terms of kind of trying to measure the effectiveness of its dissemination. But one thing I see in the FHI project that we're involved with lots of other academic partners, but they have a sort of IP management facility by which they sort of, I suppose, select out the items that they want to sort of move into the commercial arena. And I think they have what they call two kind of dimensions. One is sort of, you might say, what they call lead functional compounds, or ingredients in other words, where they are pushing out. And if they're, okay, if it's kind of patentable, it kind of goes through one sort of IP process, but essentially it is into sort of the licensing, and we say maybe a non-patentable item they call an available simple result, or an ACR. But again, like there's a kind of engagement process, you know, that's, as I said, it's industry-led, so the industry people are given the first sort of opportunity to respond to this, to engage with this opportunity. And if one, you know, does, then there's a kind of, it's time limited then, after which it falls back and is maybe offered to others outside of the industry. So it's a good way of, as I say, kind of documenting what has been done, and maybe even following through, that doesn't sort of die, which potentially can happen. Like you can get caught up in, you know, non-disclosure agreements and that sort of thing, and unless you manage it properly, you could find yourself trapped, kind of saying, oh, we kind of gave such and such a company access to this, and now we can't do anything with it, you know. So, as I say, a kind of management process there is a good thing. There was a question down there.
Thank you for your presentation. I will continue with the idea of Shim's, that there is a need for new technology development. So what is the vision, or what is your vision about the application of some encapsulation technologies for the production of infant formulas, like nano-encapsulation or micro-encapsulation, using some technologies like high-pressure homogenization, microfluidization, or ultrasonication, using some emulsion technologies like micro-emulsions, nano-emulsions, multiple emulsions, or multi-layer emulsions for the protecting of the infant formulas during heat treatment and during spray drying.
Well, I'll give a first answer to this while you're thinking about your reply, Noel. Because I have one ready-made answer here, and that is, you know, if you pick up the leaflet for this IDF conference, which will be in Dublin in April, there is a talk actually being given by a man called Vish Bandari from University of Queensland, and it's actually on that topic of powder microstructure considerations during encapsulation of lactoferrin, and it's actually in relation to infant formula. So, as I say, it's all the one more reason why to keep an eye and get yourself through this conference. But I just wanted to mention that. I said, well, Noel was thinking about other approaches.
Yeah, I mean, I've come across it myself with in the infant pharma industry that they are looking at encapsulation for protection of particularly vitamins, things that are, you know, not very heat stable. Myself, it depends on how commercially viable it is to produce encapsulation. Now, in terms of, I mean, the talk there that Phil mentioned, I mean, encapsulation, but again, it's lactoferrin, it's probably, you know, electrostatic interactions and things like that. Myself, I'm not that aware of the actual new technologies around in terms of encapsulating these these products and how stable they will be through the heat treatment system. And then again, if you are limited in terms of, as I said, the recipe and the regulations in terms of what you can actually add to infant formula to encapsulate products. And there is even some technology around looking at encapsulating insoluble calcium, so that it's not sedimented to the bottom of your tank, so that it remains in dispersion. These are all ongoing technologies. From what I've seen at the moment in terms of commercialization, it wasn't very feasible from my own experience within the pharma sector, because we did kind of explore that, But that's not to say that the technology isn't there, that it's on its way, I think that's maybe what I have at the moment.
Anyone else? No?
I'd say you're fairly covered, Seamus.
Right. Well, thanks, Paul, very much. From Engineers Ireland, the Ag Division, it definitely brings this subject to the fore. And the thing that strikes me in all of this is it's a very strong feeling I've had for years. It relates to what Seamus had mentioned there, a new product, and you covered it well, new product development. All of what is R&D, basically, in my book, has to start with basic research. Now, sometimes research can be done on a global basis, sometimes it isn't. But obviously, having the contacts globally, you need to, number one, you need to know where you stand, and then having the information, you need to be able to carry it through. That's my experience down through the years in this research. Now, applied research, I would call it, R&D people call it, sometimes a lot of work that's done is basic development. In Teagasc, for example, it's not. It's applied research, and very often through R&D. In other words, basic research, applied development. And that's the difference between a lot of other industries in the country in the process areas. Like, we have global research that's applied and brought in very often in patents and is applied in the process industry, but definitely through any of the Teagasc work that's been done, it's above that level, and it's a good example for what's in the country. Now, this has been ideally covered in Paul's paper. That paper, I should say, is on video and will be webcast from Clyde Road. So anyone who wants it, or who has a contact who wants it, it will be on the webcast. Now, otherwise, you can get a copy on USB from myself, or I'm sure Phil or Paul here, and then we can pass it on. So, again, a word of thanks from all, and thanks very much for coming.
And
Okay,
Sean will say.
Sean, have you something to say further?
Just to add a few words to that, Seamus. First of all, thanks to Noel for a fine talk, well-prepared talk, and a very impressive array of activities going on in Moorepark at the moment. So thanks to Phil and the rest of the team in Moorepark for facilitating us here tonight and providing a bit of refreshment and nourishment beforehand as well. So that's very much appreciated. To Seamus and to Engineers Ireland, on behalf of Society of Dairy Technology, this is, I suppose, one of a number of events we've had over the last year, sort of joint ventures, you might say, and it is very good bringing together, the disciplines of food science and technology and engineering, and getting a bigger view and a broader view of what's needed to drive the industry. We've for a small country, I think we certainly in three spheres, in electronics, ICT, in food, and in chemicals, pharma. We certainly have a very prominent position relative to our size internationally. And of the three of those, I suppose food is the indigenous one, and it's good to see from what came through to me from Rose's presentation tonight is that not only are we a low-cost milk producing, an efficient low-cost milk producing country, but we're also have the vision to look at adding value to what we're doing and exploiting the positives and the benefits that we have based on our grass-based milk production systems. So Phil got his plug in there about the IDF parallel sessions coming up in April. So maybe I'd take the advantage of reminding you of a few events that are coming up on the SDT calendar next year. So starting off in February, we're on a date yet to be finalised, but we do propose to team up with yourselves and Engineers Ireland, Seamus, and have a presentation just to kind of a case study of one of the major milk capex investments over the last couple of years, and hopefully maybe combine that with the site visit. So watch out. We'll be finalising this towards the end of the year, and we'll be publicising it. Also, our colleagues in the Northern Ireland section are putting on an event in February as well, and they'll be looking at going over some ground that we've gone over before in terms of water utilisation and recovery and wastewater treatment, and that'll probably be that will be held in Loughry College. Probably on the 3rd or the 17th of February. That's that date to be confirmed. Then the major event for the Society of Dairy Technology is our annual spring conference, and that's being held on the 14th and 15th of April in the University of Reading, and on the topic there is on probiotics and developments in the biological sphere and products therefrom. And our main cheese event is associated with the International Cheese Show in Nantwich in Cheshire at the end of July, and we will have a program of events on the day preceding the judging, and followed by our annual dinner that night. So lots happening in 2016, and we hope to see some of you at those events. And thank you for coming tonight, and for your questions and interest in the subject, and we should stay at home.
Thank you, Sean. One small point I forgot. Next year, it's approximately August, but there'll be a major conference it's in Grange, the Chagas Centre in Grange, on wastewater, and it's more the handling of the additional waste from intensification of production in agriculture. Now, there's a new anaerobic digestion system being constructed in Grange at the moment, so the whole thing will be of interest to everybody, I think, in the business. So I'm sorry I missed that. Nevertheless, that's there and it's being planned at the moment. Thank you. Thanks for all. Bye-bye.